All right, lesson 42, we're going to talk about finding permutations and combinations. So, one of the questions in the homework lesson was, if we can repeat digits, how many different possibilities are there for a 3-digit passcode, right? And we got 10 times 10 or 10 cubed, and we wound up with 1,000. We're going to look at different types of situations. We're going to talk about factorials. A factorial of a positive integer is the product of all positive integers up to and including that integer. Note that 0 factorial, and our symbol for factorial is an exclamation point, is defined to be 1. Because anything, it's still, well, you would think it's 0 times 1, but it's still just 1. Okay, it's kind of an odd deal. So in factorial, so the factorial of n is denoted as whatever my number is times, and they make this more complicated than really it needs to be. They're just trying to say that it'll work in every case. Give me let's say a small 2-digit number, something less than 20. Something less than 20. 15. All right. So for instance, if I wanted 15 factorial, it would look like this. Okay? And we have the capability. I don't know if have I shown you guys how to do factorials in your calculator?
I believe so. Yeah, because there was one question where you had to go from 10 to 1.
Yes. Okay. So you guys are aware of that 15 factorial is essentially 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Thank you for helping me out there, Axel. I wasn't quite sure as we got down to those smaller digits what came after. So anyway, that really helps me out. So what they're saying is 15 factorial is equal to n, which would be 15, times 15 minus 1 would be 14. All these things on down. So 15 times 14 times 13, because that's 15 minus 2, right, times 12, which is 15 minus 3, right? We see how they're drawing it out there. All the way down to, and you'll always end with 1, which 1 isn't going to end up changing the value of whatever you've multiplied, or your giant product of whatever it is, but it is there because we go all the way down. Okay? All right, a permutation is a selection of items where order is important. Okay? So and your calculator will also do permutations, just so you're aware. The permutations of n objects taken r at a time is given like this. So where we have, let's say we had we had 15 items, or 15, and we were taking 2 at a time, right? So that would be 15 factorial over 15 minus 2 factorial. So it ended up really being 15 factorial over 13 factorial, which actually should be a pretty small number, right? Yep. Because what I'm left with, right, is just what, 15 times 14? Right? So much smaller. Because the 13s on down to the 1s are all going to cancel out. Okay, so the permutations of 6 objects taken 3 at a time gives me my 6 factorial over 6 minus 3 factorial. So 6 minus 3 is 3, so I get 6 factorial over 3 factorial. So you're seeing something, when done out on paper, 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1, where we see these things cancel out. 6 times 5 is 30, 30 times 4 is 120, right? So we can do these pencil paper, right? Yep. Okay, not too hard. A permutation of n objects arranged into one group of size, or n, without repetition of objects can be found by using formula, or we're using our factorial. So for example, this is a lengthy example. Let's say we have 3 letters, A, B, and C, are arranged into groups of 3, can be calculated as 3 factorial. Or 3 times 2 times 1, okay, which is 6. We can check our calculations. So if we said we wanted all the permutations of A, B, and C, okay, And if we did this, we're going to see that that's in fact the case. We have ABC, we have ACB, okay? Basically, you take that first letter, you leave it, and then you flip the other two, and you show both combinations with the other two. So ABC, ACB, then we move B to the front, we get BAC and BCA. We move C to the front, we get CAB and CBA, right? And if you count all those up, you find that you have 6 permutations of 3 letters. Okay, when the letters are repeated, permutations are not distinguishable from each other. So for example, if we had 3 letters like B, B, and O, there's only 3 distinguishable permutations. Okay? Meaning that because we have 2 B's, we could get B, B, and O twice, but they would be indistinguishable from each other. Right? We wouldn't be able to tell the difference. It's not like we have a blue B and a red B that we can tell which B is what. Okay? So we really were just left down to Bob, BBO, and Ababa. Okay? Okay? So the number of distinguishable permutations and how we figure this out of in objects where one object is repeated a number of times, another object repeated a number of times, and so on is where we take how many items we have, we put that on top, and on the bottom we multiply by how often something is repeated. Okay? So the number of permutations. So for instance, gosh, I don't have room here. So like with Bob, okay, or BBO, all right? We have 3 letters. That's 3 factorial. B shows up twice, so that's 2 factorial. O shows up once, that's 1 factorial, or 1 times 1. Okay? So we wind up with 3 times 2 times 1, which is 6. And then we have 2 times 1, which is 2, times 1, which is still just 1. So 6 divided by 2 winds up with just those 3 permutations that we saw up here. Okay? Let's see, before we move on from there, I want to talk about, let's look at a different situation with permutations where, let's pick a word where multiple letters show up multiple times. All right? An easy one would be, let's say, Mississippi. Right? How many letters are in Mississippi? We got M, I, S, S, I, P. I mean, I know how to spell it. I'm just trying to see if you guys know how to spell it. M-I-S. Oh, you guys spelled it wrong, didn't you? M-I-S-S. M-I-S-S-I-S-S. I-P-P-I. Right? Okay. So there are 11 letters, right? So we're going to put 11 factorial on top. How many M's do I have? 1. Okay, so that's 1 factorial. How many I's? 4. So what? What do I write? 4 factorial. Okay, S's? No, I didn't. I said M and I said I. 4. Okay. 2 P's. Okay. So if I'm going to plug this in my calculator, this is how I do it. Okay. We're going to start off with 11. We're going to hit math. We're going to go over to probability. We're going to get our factorial there. Divide by, and I'm going to hit another set of parentheses because I want to divide by all of this. If I don't put this in parentheses, if I have an older calculator, it's only going to divide by the first factorial, and then it's going to multiply by all the other factorials. So it's going to wind up with a much, much bigger number than I should have. Okay? Do I really write in here 1 factorial? No. Yes? Okay, we'll do it anyway. 1 probability factorial. 4 math probability factorial. 4 math probability factorial. 2 math probability factorial. close my parentheses. So, in terms of distinguishable permutations, that's not putting an S where there was already an S, right? Or an I where there was already an I. Okay? There are 34,650 ways that we could rearrange the letters in Mississippi that are different. That make sense? Okay. Kind of neat, right? All right, so those are permutations. The next thing we're going to look at in the next page is combinations. Okay, combinations. Combination is a selection of items where order does not matter. So the combination of n objects taken R at a time. Notice that instead, like with permutations, it would look, we would block out the R, right? It was just like that. Yeah. Okay? Well, combinations adds that part of it to it. Okay? So a combination of 5 objects taken at 2 at a time becomes 5 factorial over 2 factorial times 5 minus 2 factorial. Okay? So I should end up actually with, an even smaller group. So to decide if a permutation or a combination is needed, you ask yourself if order is important. Okay? So the arrangement of digits for an alarm system code requires a specific order. Hold on a second. All right, so the arrangement of digits on an alarm system code requires a specific order. The code 352 is different from the code 235, so permutation is used to determine the possible codes, the number of possible codes. The arrangement of names of people in a study group does not require a specific order, so a combination is used to calculate the number of possible arrangements. Okay. All right. Let's take a look at some questions. Let's see if I can find. I think we used. I've already seen some of these questions. We want to go down to something that we haven't seen yet. Maybe. Where are we at here? 42. Nope. This is not even the right document. All right, here we go. All right, permutations of the letters graphed. Okay, do we have any repeat or how many letters do we have first? 7? I can't write on this. Okay, 7. All right, do I have any repeat letters? Are there any other G's? No. Any other R's? No. Any other A's? No. Any other P's? No. Any other H's? E's or D's? Okay, so what do I do here? Is it just 7 factorial? Yeah, because they're all going to be distinguishable. So what is 7 factorial? 1? What is 7 factorial? What's 7 times 6 times 5 times 4 times 3 times 2 times 1? 5,040 is what I heard. Let's check. Okay, we'll check. Number 3, 5,040. Now, he could have just looked at the bottom, but I don't know. All right, permutation of 10 objects taken 2 at a time. Okay? Now, remember, permutations is my number, factorial, over my number minus how many we're taking at a time, factorial. So I'm going to write down what? What am I writing? I need to... You look at this, we'll write down what you're going to put on your page. Let's see, this isn't what I want. Let's use this. How many objects do we have? 10. All right, so I got 10. 10, 2 at a time. 2 at a time. Okay, so 10 with 2 at a time. What's my equation? Permutations, right? That's in our notes. So let's go back and look at our notes. How do I write, if I know I have 10 with 2 at a time, and it needs to be a permutation, not a combination. What? It should be 10 factorial over,
10 factorial of 10 minus 2 factorial.
okay, 10 factorial over 10 minus 2 factorial. All right. Now, that will simplify to be what? 10 factorial over 8 factorial, which means 8 factorial will cancel out, right? Leaving me with what? 10 times 9, right?
Yeah.
Because everything else below is going to cancel out, so my answer should be 90. All right? So do you see how once you know your formula, I mean, you could still plug that in your calculator, right? But, I mean, I think I could probably have solved that faster than you could have plugged it in. So do you guys know how to show your work for these? Hopefully. Okay, let's come back over and see if that was our answer. Was it number 4?
Yeah.
90 was our answer. 5, 9. What? 4? Oh, because number 5 is combinations, right? Combinations adds a little bit to it. Okay? Same kind of thing, but combinations. Okay? Where we have 10 with 2 at a time. Okay? What equation do I write here?
10 factorial.
All right, so Angeli got the numerator. Somebody else gets the denominator. Somebody I haven't heard from. Really, I haven't heard from Danielle, Allison, or Jewel all day. I want to hear from one of you. No? 2 factorial, good.
Parentheses 10 minus 2 parentheses factorial.
Very good. Okay. All right, let's simplify that. On the top, I still have 10 factorial. On the bottom, what? Can I simplify?
8 factorial. Yeah.
So I should have 2 factorial, 8 factorial, right?
Yeah.
So the 8 factorial still cancels out, right? Leaving me with 10 times 9 over
Which is just 2.
over 2. So 90 divided by 2 now is 45. So I have fewer combinations than I have permutations. Does this make sense?
I'm kind of confused on how you get 9 from the 8. Like 10 and 8.
Okay, let me show you. Let's do it in expanded form, okay? Because you weren't sure how I got 10 times 9, right? All right, so expanded, this is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all over 2 times 1 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, in which case my 8 factorial will cancel out, which leaves 10 times 9 left, okay, and 2 times 1 on the bottom, which is 2. Does that make sense? And that would have answered your question if you were wondering about that from the earlier part too. Okay? All right, are we good there? Yes? So we understand how to, I mean, we want to be careful. If they say combinations, we need to set it up as a combination. If they say permutations, we need to set it up as a permutation. All right, let's look at some questions. Let's see, this is lesson 42. A through J, right? I think that you guys could do A and B just fine. Think you could do C fine. How do you feel about D? You can do that? Okay. All right. So Angeli, speaking for herself, says she can do that. Is there a question there that you want to see? You think, hey, I might not be able to do that one. No, that's funny. H, I?
You're saying if you want H, you're saying if you want I.
They're kind of the same thing.
H and I are the same thing. So which one? Okay, let's look at H. Yeah, and they both draw themselves back to the same example. How many different 4-card hands are possible if you draw 4 cards from a standard deck of 52? Is this a permutation or combination problem? All right, well, if you go, let's go over to example number 4 real quick. Let's see. Example number 4, they say explain whether the following is a combination or permutation and find the solution. How many 2-letter arrangements can be formed from the letters cat? Does order make a difference? Okay, in this problem. Okay, let's see. How many 2-letter arrangements can be formed from the letters C-A-T? Does the order matter?
No.
No. Okay, or I guess they say that it does because in that it says order makes a difference in this problem because CA and AC are not the same arrangement. So saying what they mean by whenever they say does order matter, what they mean is does the order change anything? And it does. If you rearrange the letters, the order does change it. Okay? So the solution is a permutation. Okay? Let's see. So if we go back to our question on H, how many different 4-card hands are possible if you draw 4 cards from a deck? Now, in which one is order important? Is it permutation or combination? Permutation is where order matters, right? Okay. So in a deck of cards, does the order matter? You're taking 4 at a time. Are they looking at the order of those 4 cards? No. Okay. So it's just combination, right? Okay. So let's see. How many different 4-card hands are possible? So how many cards are there? So we have 52 taken 4 at a time. Right? Okay, and we said this is a combination problem, correct? So how do we set this up? It's a combination question. Factorial.
Factorial over how many 4 at a time?
Yep.
So 4 factorial parentheses 52 minus 4. And then
Factorial. Okay, try that. Plug that in, see what you get. Okay, now remember, when you do this in your calculator, what you are typing in is parentheses, 52 factorial, close parentheses, divide by parentheses, 4 factorial, parentheses, 52 minus 4, close parentheses, factorial, close parentheses. Okay, that's what you want to type. And then I'll show you a different way. But I want to see that you get the right answer first. Okay, 270,725. That is correct. Okay. I want to show you something else that your calculator will do. If you know it's a combination, okay? Okay, we have something called NCR. So I can write 52 math NCR 4. It will also do permutations. But except instead of NCR, you're going to use NPR. But I want you to know principles. Okay? All right, we'll see you.